All right. Hello, everybody. Time for our next session. This one is going to be on collaborating in MakeCode Arcade. But before we get started with that, I think we need to do a round of introductions because I'm not here by myself today. I'm Richard. I'm a developer on the MakeCode team. And let's just go in order starting from the top. So, Thomas.
Sure thing. My name is Thomas, also a developer on the MakeCode team.
I'm Sarah, also a dev on the MakeCode team.
I am Ben. I was a developer on the MakeCode team, and now I'm on the Visual Studio Code for Education team.
And I'm Joey. I'll give you a guess what I am.
Yeah. So as you've gathered, we're the developers on MakeCode. Not all of them, but most of them. And we do a live stream 3 times a week. And we do a lot of coding on that live stream. We do a lot of collaboration. So I'm usually the one who's doing like the main coding, but we do a lot of sharing of projects. And through the years, through the forums and talking to teachers and all sorts of things, we've seen a lot of different ways that people have for collaborating on projects in MakeCode Arcade. So what we're going to be going through today is some of the things that we have learned from seeing how people actually collaborate on projects in MakeCode Arcade, and just some suggestions on how you can do like assigning group projects and the like in the classroom when you are working with Arcade. So with that, let's get started. First though, live stream. So live stream is every Monday, Wednesday, and Friday at 1 o'clock Pacific time. And you can watch us on Twitch, YouTube, and Facebook. And if you can't catch us live, we put all of the videos up on YouTube afterwards, so you can also just watch them there. Also, I would say everyone here is very active on the MakeCode forums, so you can also at pretty much any of us on the MakeCode forums. I am Richard. Yeah, let's get started. So project collaboration. This is a pretty common pain point in the classroom. I think it's kind of especially difficult for coding classes because there is the necessity to like share code back and forth. And this is a scenario that we want to improve. I think we know that this is not a perfect scenario in MakeCode today, but there are some ways to make it easier, and that's kind of what I'm going to be walking you through. So I'm going to be talking about 4 different ways of collaborating on projects and kind of some benefits and drawbacks to each. So the first one is going to be just like passing links back and forth. Then we're going to be doing some new features that are in Arcade, which is copy and paste between projects and a couple other ones. We'll get to them one by one. But let's actually start out with the age-old way of sharing code for class assignments, which is passing links back and forth. Chances are this is how students come up with it, their way to share things like on their own. The most basic way of sharing projects in MakeCode Arcade is student A works on a project, student A creates a share link and sends that to student B. Student B then imports that share link, makes edits to the project, and student B creates another share link and sends it back. Rinse and repeat. This is kind of like the classic way of just sending files back and forth. And it has some benefits. Namely, you automatically are creating a bunch of backups of your project each time you share, which is nice. Every time you re-import the project, you are creating another version of it. So if something goes wrong, it's pretty easy to go back to old versions of the project. And also, you don't have to deal with merging code because only one person is ever coding at a time, which also brings us to the very big drawback with this, which is that realistically, only one student can work on this code at any time. And also, creating many versions of the project can be messy. I don't know which version is the most recently shared. I don't know if I'm working on the right version or if I'm working on 3 versions ago because I have to mentally keep track of all of these different versions that are being sent to me. So while passing links works, it's not really the ideal scenario. Luckily, we've been making some improvements to Arcade. We did a release earlier this year, and with that came a new feature that makes a collaboration a lot easier, and that is copy paste. Yeah, so copy and paste. MakeCode's always had copy paste, right? But what we didn't have was the ability to copy and paste blocks between projects. So the vast majority of projects that are made in MakeCode are blocks first projects. And in the past, when people wanted to collaborate on blocks projects, they would have to switch to JavaScript, copy and paste the text code, and then switch back to blocks. Which, if you've done that before, you know that it doesn't. A lot of times, your blocks end up getting moved around. It's not a perfect transition, and so it can be a little problematic. But with now being able to copy and paste blocks between projects, it becomes very easy for students to merge separate work streams. So the way that we recommend doing this, and we're actually going to be doing a demo of this today, I'll get into details of that in a bit, but is you divide the project into separate work streams. So for example, you might have student A who will be implementing like the base gameplay. Student B might be working on like the HUD and information that gets displayed on the screen. Student 3 could be implementing a menu for the game, so on and so forth. It's really up to what project they're working on. Then students sit together and they merge the projects by taking all the different share links. And because this is a new feature in Arcade, and there are a few gotchas, we wanted to demo this today. So we have actually prepared some projects that we're going to live code at the end of this presentation. And I have contributions from all of my co-hosts who are not visible anymore, but Thomas, Joey, Ben, and Sarah. And I'm going to be merging those projects together using this copy and paste. So stay tuned for a practical demo if you'd like to see that at the end. So benefits of this approach. Students can work on projects at the same time or asynchronously. That's great. It teaches good software engineering principles because you kind of have to decide how you're going to be separating these features so that they're kind of self-contained. The drawback to this approach is that merging, while is much easier than merging with like the sharing link method, it can still be a little tricky. There are some gotchas, which I'll get to in just a second, for like warnings you should give to students so that they don't end up making projects that are difficult to merge afterwards. And then finally, it does require careful planning of the various tasks, but that can be done by the teacher or whoever is assigning a project in addition, or it can just be a really good experience for the kids to kind of get together and decide at the beginning how they need to chunk up this project that they're working on. So, like I said, I'll be doing a demo of this in a bit, but some pitfalls to keep in mind. Before you copy and paste, it's a very good idea to make sure that you have a backup of the project you're pasting into. You can undo copy and paste. It's totally fine. And typically a project will survive just fine. But kids have a habit to sometimes refresh the page or something like that, and they can end up losing the undo redo history, which can end up, leading to tears and broken projects. So it's a good idea always to make sure that everything is saved before you start doing a merge. And then next, both projects should have the same extensions installed. You will actually get a warning if you don't have the same extensions installed. It won't let you copy and paste. So this one's an easy to remember. It'll let you know if you didn't do it right. And then finally, it's important to make sure that the projects use different variable names. You'll see some strategies of this when we merge our code together. For our example that we're going to be doing, we actually decided on what extensions should be installed ahead of time. So I have those installed in a project that I'll show you in a bit. All right, so that's copy and paste. There's two more strategies I want to go through real quick. The next one is what we like to call Project Game Studio. So the idea here is that, like a game studio, you have students take on separate roles when they are developing a game. So you might have a coder, an artist, a level designer, play tester, project manager, those sorts of things. And each student gets to inhabit that role for a certain amount of time, and then they rotate so that all students get a chance to do all of the various things. One note here is that all MakeCode asset editors support copy and paste. It's very easy to copy images from one project to another or levels and the like. So having artist and level designer be separate projects is actually pretty easy to do. So, benefit of this is how actual games get made. Teaches you about how some software engineering stuff actually happens and how you have to kind of integrate a bunch of different work streams, which is great. And there are no problems with merging code because there's only one coder at a time. But the obvious drawback to this approach is that it is not suited for non-game projects. If you are trying to do a recursive implementation of the Fibonacci sequence, there's not an artist for that one, so it's a little bit harder to chunk that up. All right. Finally, there's one other thing that I did feel like we had to mention because we've definitely seen people try to use it on the forum, which is GitHub. So if you're not familiar with GitHub, I'm not going to be doing a whole introduction on how GitHub works today, but it lets you have repositories of code that can be shared between multiple people and then merged together. So the basic idea here is that students create a shared repository in GitHub and each import the repo into MakeCode. And then each student would then commit locally and pull from the central repo to have everything together. Now, I'm not going to go super in depth into GitHub because in general, I would not recommend it for the classroom scenario unless you are already teaching Git and GitHub for your class as a whole. So the benefits, of course, GitHub is a very useful tool to learn and use. And it's very easy to restore old versions of the project if something goes wrong. The drawbacks, though, is that GitHub is quite complicated. Yes, we have a question for Brittany. Do students have to have their own account to use GitHub? They do. And this is also not recommended for blocks projects. Merging things like blocks is not something that Git or GitHub is particularly good at. And while we have plans on how to make this better in the future, for now, you end up with a lot of merge conflicts, and merge conflicts are difficult for students to resolve. So while I think with any coder, it's very important for them to learn how to use source control and things like GitHub in the future. In the classroom scenario, if you're not already integrating that into your curriculum, trying to add GitHub on top of basic learning to code can be a little bit difficult. So my last 2 points are, as we mentioned, everyone needs to have a GitHub account. And also, GitHub is often blocked in school. So you obviously will know if this applies to you or not. But a lot of school intranets block GitHub for whatever reason, which can make it difficult to use in the classroom. All right. So those are all of our different collaboration things. It's demo time. So for this demo, I have everybody add yourselves back in. For this demo, I have we came up with an idea for a game yesterday, and I have tasked all of my co-hosts with making projects that we are going to merge together. So Sarah, would you like to say what the game idea we had was?
I didn't come up with the name, so I don't think I'm qualified.
Okay,
I think either
right.
Thomas or Ben. I don't know.
All right, someone say it. Thomas, go ahead.
All right. Well, since I did the title screen, I unilaterally decided the name of this game is Banana Bonanza. We will be running around collecting monkeys. I'm not sure if we'll be a duck today, Richard, or something else, but I leave that to you.
We'll see. So we divided up all of this work beforehand. We gave everybody a different task. I'm going to be coding the base gameplay of the game live here. We'll be starting in a second. I'm going to be starting from a blank project. But let's go through real quick what everybody's task was. So Sarah?
I got the HUD. So
Yeah.
how many monkeys you collected? I'm seeing it on the screen.
Yep, and as I mentioned, I did the title screen.
I got the level design.
And I just made the monkey so that it jumps around. Yeah.
Joey was in charge of monkey AI, just like the proverbial monkeys at the typewriter. So let's get started. I've already got the links from all these folks that I'm going to be merging in a second, but let's switch over to Arcade real quick. There you go.
While we're swapping over.
What's up?
While we're swapping over, we did do this live last Wednesday on live stream.
That's true.
We just didn't want to do it here because we had 30 minutes. So
yeah, because we are tight on time today, we decided to prepare beforehand. But if you want to see us doing this live, we did do it last Wednesday, and I did indeed spring it on my co-host, so they didn't even know we were doing it beforehand. All right. So we're going to be coding a platformer where we run around and we collect monkeys. So I'm going to be coding a platformer up real quick. Now, I'm starting from a blank project, but I've already added some extensions, mainly the tile util, character animations, fancy text, timers, sprite utils, a bunch of extensions that we figured we were probably going to need for this project. So we all agreed that we were going to be using beforehand. And just to make the copy and pasting easier. But to get started, I'm going to code up a platformer real quick. So I'm going to create a player sprite. We are going to make him a duck. I love the duck. So we got to go with the duck. And we're going to be giving this duck some gravity because it's a platformer. So I'm going to give it some acceleration Y. Set that to 500. I'm going to add some controls. So I'll set the VY to be 0, but we're going to have VX so that I can move left and right. And we are going to have the camera follow our duck. The last thing we have to do to make this a platformer is we need to have controls for jumping. So I'm going to grab an on A button pressed, and I'm going to have an if statement, and we're going to be checking if we are on the ground. And if we're on the ground, then we're going to do a jump. So let's do a if hitting wall, change this to bottom to make sure that we're on the ground. And then we are going to set the velocity of our sprite to be something negative. I'm just going to do negative 200 because that'll probably work. You know, we can tune these values later. All right. So here we go. We have the base platformer game. I am now going to integrate my co-host's code, and I'm going to start with our level designer's code, which is Ben. So, Ben, do you have any introduction for the code I'm about to import?
You're muted, Ben.
Do it again.
I think this is one of the greatest levels ever made, if I could claim such a thing.
Yep.
Take a look at that. We got plenty of monkeys there. We got some platforming that's got to happen.
Yeah.
And yeah.
Looks good.
I think the level speaks for itself.
I asked Ben beforehand to put in 2 special kinds of tiles that we're going to be using, which is a monkey tile for where we need to spawn the monkeys and a spawn tile for where we're going to spawn the player. So that's what these are. Anyway, I'm going to go ahead and copy and paste this. So I'm just going to be using Control C and then head over here, Control V, and there we go. We have the tile map and all pasted into our project, and we can now see this show up. All right. So I want to do the code to, if we have a question, where are the monkeys? They're coming, I promise.
Well, they're right there already. You can
yeah,
see
that's
them.
true. The faces are there staring at us with a
Got a nice smirk and everything.
Yeah. So I want to spawn my player on top of that spawn location. So I'm going to go ahead and code that up real quick. I'm going to grab an on tile map loaded event right here. I'm going to grab from scene. We're going to do a place on top of random location. And we're going to change this to be our spawn. And now our player should jump up there. So there we go. Looks good. And we're also going to cover up all of these special tiles because we don't actually want the player to see them. So I'm going to grab the cover all block from tile util. And I'm going to cover all of the spawn tiles with the backgrounds. Oops. And I'm going to cover up the monkeys too. All right. Okay. Next up, I'm going to grab the code from our monkey designer in chief, Joey. Joey, do you have any words to say?
I mean, it's a monkey. It jumps back and forth. I guess one thing to note is that we did try and make an emphasis to make this one easy to copy. So it might not be as smooth. You might have to copy some more variables or some more chunks. But this one, we tried to put it in all in one function so that it's just easy to just take it all out. That's something you might encourage in your classroom.
Yes, that is a tip. It's a very good idea to have students do like one function because that makes it very easy to then copy and paste this code because you're just going to copy one big chunk. You can definitely copy smaller events, but we don't currently today have a way to select multiple blocks at once. So collecting a thing is, nice and easy. So I'm going to go ahead and copy this place monkey function, and we're going to switch back over to our project, paste that in there. And I'm going to call this place monkey so that I place them on all of our monkey tiles. So to do that, I'm going to need a for of loop. I'm going to go into scene, and I'm going to get the list of all monkey locations. And we're going to go ahead and place our monkey on those locations. So we should now have a game that has a bunch of monkeys in it. Go. Whoops. Do I have a problem in my code?
Mm-hmm. Oh.
Whoa.
Oh, it dragged out. Oh.
Oh,
I see
wow.
what happened here. Okay. I can fix this real quick.
Bug we'll have to fix.
Yeah. Technical difficulties.
That's what happens when you code live every time.
Yep. If you didn't have technical difficulties when you code live, were you even coding live?
It's true. This is how you can
Murphy's
tell
Law.
that it's real. Yeah, we didn't test everything beforehand. There we go. All right.
Yeah.
There we go. Now we have a world full of monkeys who are jumping around in all of the locations that were specified by Ben. All right. So that's great. Let's go ahead and catch these monkeys. For that, we're going to need to display how many monkeys we have. So I'm going to go ahead and copy Sarah's code next. Sarah, do you have an introduction?
I made it yellow because I think of bananas when I think of monkeys.
Yep. That's what they eat.
Me too, Sarah. Me too.
So we have a monkey thing up here. If I press A, it's going to increase the number of monkeys. And we're going to use this to keep track of that in our game. So I'm going to grab this render on Z index and paste that over in my project right here. And then Sarah also made a catch monkey function for increasing that number. So I'm going to copy that over as well. And now I want to catch these monkeys. So I'm going to do an on sprite overlaps. Oh, whoops, not that. I want this guy right here. We're going to do a overlap between player and enemy because our monkeys are kind enemy. And I'm going to just destroy that monkey. Oh, that sounds bad. Don't destroy monkeys.
No monkeys were hurt in the making of this game.
It's true. And we're going to call the catch monkey function. And now I can go and catch those monkeys. There we go. Great. Okay. And now, finally, we need the title screen of our game, which was made by Thomas. And let's go ahead and grab that. Thomas, do you have an introduction?
Well, like Sarah, when I think monkey, I think banana. So despite the fact that this game unfortunately has no actual bananas, the bananas are in our heart, and it's still called Banana Bonanza. So,
Yeah, and we could add bananas to this at some point. Is a
Yeah.
game ever truly finished?
no, I'll
Um,
follow the work item.
I mean, it used to be when you have to put it on a cartridge, but yeah. Relatable much. Monkey plus bananas equals yellow. Very true. All right, so we have our little title screen here, and if we press A, the monkey jumps away, and we start the game. So our code is divided into two functions here. It looks like we have a show title and dismiss title. So let's go ahead and copy both those over. And we're going to copy dismiss title, paste
Yeah,
that
actually,
in.
We'll have to be a little bit
and-
careful here because
Yeah, so you may have noticed that this function got created when I pasted this in. That's because it's referenced inside of this function. I probably should have copied this one first, but it's okay. I can just take the blocks from this function and go ahead and stick it in there. All right. Also, there is sound in this title screen, and it's delightful, but you won't be able to hear it because I did not share with audio this time because that can cause problems with echo and such. So, all right. So we're going to call this show title function at the beginning of our game over here. And let's go ahead and do that. So I'm going to grab the show title function. I'm going to put it at the top of my onStart. And now we have Banana Bonanza. Press A to start. Ooh, failed cast on null. Yeah, so I have this on A button pressed code, which is using the mySprite variable. And so I need to make sure that mySprite is defined before I actually trigger any of this code. Luckily, that's easy to do. I can just go ahead and do if mySprite. But it's a good idea why it's like you should discuss controls and the like beforehand, because that's kind of a big place where a lot of code ends up sharing stuff. And it's a good idea to work these things out before you do the project. All right. So with that, I think that we have finished our example. So we have Banana Bonanza with our monkey counter, our title screen, and our monkeys with their wonderful AI of jumping all over the place and laughing at us. And of course, if I was making this to an actual game, I'd probably make it so that there was a way to win and get scores or a timer, things like that. You know, you can work on this till the cows come home. But I hope that this was a nice little demo of how you can use copy and paste to kind of merge some projects together. With that, I think that brings us to the end of our presentation. So let me actually share this again. Whoops.
Let's see, I didn't know you could just use a sprite in an if block. Yeah, you can put any variable in just an if block because we follow the same semantics as JavaScript in that.
Yes.
The gotcha though is that once a sprite has been defined, it'll always be true. It just doesn't exist, so it could be destroyed. So you have to check other ways if it's been destroyed if you want to check that.
Yes. If you want a more robust way to check if a sprite is defined or not, you can actually grab the is sprite destroyed block from Joey's Arcade Sprite Utils extension, which, you know, perhaps we will put up some other a link for that later. But that will also check if it's defined or not. So it's a better way to do this. All right. So we have some questions real quick. How do you get each other's links? So that's going to be defined by the classroom. So you can either just share them. Our share dialog has a QR code. So you can share QR codes between each other. But otherwise, it's going to be really defined for your classroom. If they have a school email or if they are just on different laptops and can walk next to each other to type them in. Our share codes are actually made to be easy to type. We avoid similar letters and the like to make sure that they're easy to type from one screen to another. Especially if you go to the actual share page and you get what we call the credit card number, which has a bunch of numbers as opposed to the letter combination.
It's also possible, Richard, that people don't know what sharing looks like. That might also be the question. I don't know if we want to try to show that off really quick.
Sure, I can show that off real quick. So I did kind of come in here with an assumption that you know what sharing looks like, but in case that you don't, to share a project in MakeCode Arcade, there's this share icon up here. And when you click this and click share project, you generate a link to your game, which can then be used to either share with someone to play it or to import into the editor so that you can work on that project or copy and paste from it and the like. So, all right, we're out of time now. So last thing I want to mention is we have a code for this session, which is theme. Please fill out the survey. It's the same link that you've had for all the other sessions. And thank you. If you have any questions, I'm at Richard in the MakeCode forum, or I'll be hanging around here all day and producing a lot of the sessions in the afternoon. So if you ask a question, chances are it'll make it to me somehow. Thank you, everybody. And I think that's it for us. So see you later.
Thanks. Bye.